everyone, I'm teacher Ragini and welcome to Form 2 Maths. Today we're going to enter the very first chapter of Form 2 Maths, which is patterns and sequences. Right, let me go ahead and share my screen. Okay, when I say patterns, right, what do you think about when I say the word patterns? Patterns is like something pretty, right? Okay, some kind of designs, colors, and so on. Okay, but actually in maths, we have patterns as well. Let's look at the patterns in maths here, in numbers. Okay, patterns is an arrangement. It's an arrangement of shapes, colors, numbers, letters, and many more. Okay, it enables us to identify and describe the behavior of the next object or event. So basically, when we have a pattern, we can predict what's going to happen next. For example, look at this here, 2, 4, 6, and 8. These are all even numbers. And can we kind of predict what's going to happen next? For 2 to become 4, we have to plus 2. 4 to become 6, we have to plus 2 as well. For 6 to become 8, we plus 2. And finally, what's going to be the next one? It's going to be 10, okay? 8 plus 2. 10, and then 12, and then 14, and so on, right? So a set of even numbers starts with 2, and the pattern is adding 2 to each subsequent number. How about for odd numbers? Odd numbers are 1, 3, 5, and 7. So odd numbers will start with 1, and the pattern is also adding 2. So we start with 1, then we plus 2, so we can get 3. Then we plus 2, then we can get 5, and plus 2 again, 7, and followed by 9, 11, 13, and so on. Okay, so this is a pattern in numbers. How about this one? C. This is known as the Fibonacci numbers. What is the pattern in Fibonacci numbers? Pattern in Fibonacci numbers are 1, 2, 3, 1, 1, 2, 3, 5, 8, 13, 21. How did they come up with this? Can you see? It's actually 1 plus 1, you get 2. And then 1 plus 2, okay, 1 plus 2, you get your 3. And then 2 plus 3, you get 5. 3 plus 5, you get 8. 5 plus 8, you get 13. 8 plus 13, you get 21, right? And it goes on like this, okay? So this is one of the patterns that exist in numbers in maths as well, right? So it's not just odd numbers, even numbers. There are many, many different types of patterns. This one is not that consistent like the previous one, right? Even numbers 2, 4, 6, 8. This one is a bit more, it's a bit weird, okay? But this is a pattern as well because you can keep on doing the same thing and getting bigger and bigger numbers, more and more numbers, right? Okay. So in a set of Fibonacci numbers, the first two numbers are 1. And the pattern of each subsequent number is the sum of the two numbers before it. So this is the pattern. Okay. How about D? The set of numbers in the diagram on the right is known as Pascal's triangle. This is a different one, yeah? This is yet another different one. All right. So each number in Pascal's triangle is the direct sum of the two numbers on top. Direct sum of the two numbers on top, where each row starts and ends with 1. Right. So starts with 1, and then each row starts and ends with 1. This is going to be the direct sum. 1 plus 1 is 2. All right. And then 1 plus 2 is 3. And then again here is also 3. 1 plus 2 is 3. All right. And then 3 plus 1 is 4. And 3 plus 1 is 4. And 3 plus 3 is 6. So this is a triangle that they have come up with. This is a type of number pattern sequence as well. All right. So from this, we can see that, from this, we can see that there are many patterns of numbers on rows and also diagonals in this triangle. For instance, the sum of each row will form a list of numbers. The sum of numbers in each row, sum of numbers in each row. It will come up with 1, 2, 4, 8, and 16. Where is this? Yeah, you can see it here. Okay. If I make this triangle and then I sum up everything inside that row, okay, 1, 1 plus 1, 1 plus 2 plus 1, 1 plus 3 plus 3 plus 1. I can get this kind of a pattern. And what else? What else can I get? What other patterns can I get over here? List of numbers 1, 3, 6, 10, 15, 21. This is the triangular numbers. Let's see where this is. 1, 3, 6, 10, 15, 21. Over here. 1, 3, 6, 10, 15, 21. It's kind of like a diagonal going across, right? So this is another pattern that we can observe over here. Okay? Okay. When we are describing a pattern, we must state the beginning of the pattern and each change that happens in the pattern. Okay? So let's take a look at a sample question. Let's take a look at this together, yeah? Okay. A pattern is an arrangement of numbers, colors, shapes, and letters. Sequence of whole numbers is as follows, okay? Whole numbers. Whole numbers are, we start with 0, and then 1, 2, 3, 4, 5, 6, 7, and go on, okay? Sequence of even numbers is 2, 4, 6, 8, 10, 12, 14, and so on. And odd numbers is 1, 3, 5, 7, 9, 11, 13, and so on. Okay, when we put comma, dot, 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 it means that the pattern will continue and continue. Okay, let's look at this one over here. Describe the pattern. It's telling you to describe. So when we see numbers like this, okay, they give you 1, 4, 7, and 10. How can we describe this? We describe it. First, we try to identify what actually happened. 1 to 4. What actually happened here? It's actually plus 3. Okay, 4 to 7 is also plus 3. 7 to 10 is also plus 3. So we answer this. The answer is add 3 to the previous number. All right, is that clear? Simple, right? Okay, if I give you a pattern, if I give you a number like this, sequence 30, 25, 20, and 15. What's actually happening here? What's the pattern? How do I describe it? I need to subtract 5. Subtract 5 from the previous number. All right? And patterns can also be multiplication or division. So 3, 6, 12, and 24. So we can see that it's actually multiplied by 2 each time. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. Right? So the pattern is multiply the previous number by 2. And then the last one, 320 followed by 160, 80, and 40. So we know that it's actually divide the previous number by 2. Okay, can we try this one? What's actually happening over here? How did 3 become 6? It's actually plus 3. And 6 becomes 9 plus 3. And 9 becomes 12 plus 3. So we know that this is actually, what's the pattern? Add 3 to the previous number, right? There's a moment, yeah. Okay, how about number 2? Let's look at number 2. What's happening in number 2? How did 29 become 25? It's actually subtract 4 and subtract 4 and subtract 4. So what is our answer? What is the pattern? The pattern is subtract 4 from the previous number. Right? Simple. Okay. How about number 3? take a look at number 3 and also number 4. What's happening over here? How did -9 become -4? This is actually add 5 and add 5 and add 5. So our pattern is how do we write it? Add 5 to the previous number. And the last one, what's happening here? How does 128 become 32? Maybe we can't imagine, right? Because the number is a bit big. Okay, let's look at the following one first. 32 becomes 8. We know this because we learn multiplication and division in primary school, right? It's actually divide 4. So we check this one. Oh yeah, this is also actually divide 4. Okay. So what is our pattern? Divide the previous number by 4. Right? Simple enough. Easy. Okay. So this brings us to the end of this subtopic. And thank you all for joining me, and I will see you guys in the next one.